Compressible Flow tutorial number 21. Air at 200 kPa absolute and 20 degrees Celsius pass through a normal shock wave with a strength so that M2 equals 0.5. Calculate V1, P2 and ρ2. In previous lesson, we usually use this equation to find M2 by substituting M1. So this is the common equation that we have. However, because we are dealing with compressible flow without any losses between before shock wave and after shock wave, so that we could use similar equation to determine M1 by substituting M2. However, we must write that equation become like this. We could change the M2 here into M1 and we use M2 here instead of M1. However, the whole equation, another structure in this equation is remain the same. So we could determine the M1 by having this equation. From above equation, we substitute the value of M1 here by substituting M2 equals 2.0. Here we could have M1 square is 7.0. Then we need to calculate the value of M1. We root 7.0, we could get 2.645. Then we could calculate the velocity by using this equation, Mach number times surd kRt. We substitute all the value here, we could get that velocity before the shock wave is 907.5 meter per second. To calculate the pressure after the shock wave, we use the pressure ratio of this one, P2 over P1, and this equation, we substitute the value of M1 that we get here. We substitute the value of K equal 1.4, then we could get the ratio of P2 over P1 is equal 7.9953625. Then to get the value of P2 here, we multiply this value with the pressure before the shock wave, which is 200 kPa absolute. Finally, we could say that pressure after the shock wave will become 1599.1 kPa absolute. To calculate the temperature after the shock wave, again we will use this equation T2 over T1. We substitute all the values, we could get it is around 2.284. Then to get the value of temperature T2, the temperature after the shock wave, we multiply this number with 293 Kelvin, which is the temperature before the shock wave, to get 669.5 Kelvin. To get the density after the shock wave, we could use the ideal gas law, P2 equal ρ2 equal P2 over RT2, and it will give us 8.322 kilogram over per meter cube.